Yeehaw! Okay, so today's lesson, we're going to get into the wonderful world of graphing. Trigonometric functions. We're just going to focus in this section is the sine and cosine. That's where you want to begin. So we'll begin with the basics. Like I've been saying, you always refer to the god of trig, which is the unit circle. So what we're going to do on this is we're going to fill out a table of values, and I'm picking certain values on purpose, and we're going to go from negative 2 pi to 2 pi. When you do a graph, your x-axis always needs to be in radians. You don't ever want to do a graph where you have degree values on that. That's not good. I mean, you can, but a radian is a real number measure, and we want real numbers on our axis. So actually what we're going to do is just go to the unit circle, real simple. So remember, the sine is the y value. So I'll just go around the unit circle and do this. So the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. And then from there, we just keep repeating that over and over again. So we got a 1 there, got a 0 there, a negative 1 here. And when we make it all the way around to 2 pi, we're back to 0 like that then. Okay? So what we'd end up having is these values. Put that in there wrong. So that is negative 1 like that. If we go backwards in the unit circle, you'll kind of see the same pattern, same periodic pattern. So if we go to negative pi over 2, we're back to negative 1. We go to negative pi, we're at 0. And then negative 3 pi over 2, we're at 1. And then all the way around the circle clockwise takes you back to 0. So those numbers are just coming from the unit circle. Now what we're going to do on our graph is we need to always label everything. So we're going to chop up the x-axis like this. We're going to call that pi over 2. This is pi. This is 3 pi over 2. And then that's 2 pi like that. So you want to always write that stuff down when you do that then. I'm going to write that just a little bit clearer on here. And I'm going to zoom on this a little bit because it's a little easier for me to write this way. Okay, so again, pi over 2, pi, 3 pi over 2, and 2 pi. And then you want to do the negative ones. We have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And let's see, we're going to go, notice that the biggest y value is 1. That's kind of your maximum. The minimum y value is negative 1. So I'm going to do this like this. I'm going to go all the way up 1, 2, 3, 4. I'm going to call that 1. And then I'm going to go down the same way to negative 1 like that. So 1, 2, 3, 4. Just kind of spread it out a little bit so it's nice and readable. So really all we're going to do now is just plot these points. So negative 2 pi 0 is a point. Negative 3 pi goes up to the max of 1. Negative pi 0. Negative pi over 2 negative 1. And then 0, 0. And then you'll kind of connect that into a nice smooth continuous curve like that. And then continuing pi over 2 1. Pi 0. 3 pi over 2 negative 1. 2 pi 0 like that. So what I'm doing is getting values from the unit circle, and then I'm plotting the points. So that would be what the graph of sine x looks like. That's a sine wave. So there are several definitions and things we want to look at on here. The first thing is the general shape of the sine wave repeats itself periodically. So you'll notice on this it's just going to repeat that over and over again. That's why we call the sine a periodic function, because it continues to repeat the same pattern over and over again. The reason it does is because of coterminal angles. As you go more and more laps around the circle, you just keep getting the same values over and over again. Okay, the distance measured from the beginning of the wave to the end is called the period. So that's an important vocabulary word that we do is that. So here, this is how you can kind of think of that. You can actually start wherever you want to, but I'm just going to begin the wave here. And then I'm going to go through a cycle. So I can make it all the way up to the top, back to the x-axis, to the minimum, and back to the beginning. See, that's what repeats itself. So I'm going to highlight that right there. So that would be what we call 2 periods there. So the period would really be from there to there. Okay, that would be 1 period from 0 to 2 pi. Okay, the sine wave is often called a sinusoid or a sinusoidal function. And the sine wave has 5 key points: the starting point, maximum, midpoint, minimum, endpoint. And that's what I did right here, which is worth notating. That's the first point. That's the maximum. We call this the midpoint. This is the minimum. And that's the endpoint, like that. And it's going to cycle through those points over and over again. Okay, if you went over here, it would be 1, 2, 3, 4, and 5, like that. And it does that over and over again. All right. So the next thing is the domain of the function. The domain of the sine is everything. Okay, if you look at your unit circle, you'll always get a y value. So the key thing is the sine is defined to be the y value. Well, if you look at your unit circle, there's no place where y is undefined. All the way around the unit circle, you're always going to be getting values of y. So therefore, we would say, either we could say the set of x is any real number, or in interval notation, you just say negative infinity to infinity. Okay? The range is all y values. Well, if you look at your graph, it just basically goes like this. You have a minimum here of -1. You have a maximum there, and I'm giving this as y values of +1. So that range goes from -1 to 1. And it includes those two things. Okay, so when you write your range, you could either say set of y such that -1 is less than or equal to y less than or equal to 1. And it's important you have the less than or equal to. Or in interval notation, you say bracket -1, +1, bracket, like that. Okay, and all this stuff comes from the unit circle. And again, if you look at the unit circle, it really kind of explains all that for you. The domain is the value of the sine is the y value. So y can be anything. Don't get confused on this domain and range thing either. It's sometimes easier to look at this on the graph. So the point is, no matter what the angle is, you always get a value of the sine. And the range is 1 to -1. Okay, the value of the sine is going to go from -1 to 1. Okay, so think about that a little bit. So that is the basic graph of the sine wave, like that. Okay, we're going to do the same thing on the next page with a cosine. All right, so let's move on to the cosine graph. So we're going to repeat what we just did. Now we're going to look at the graph of the cosine. And again, remember on a unit circle that the cosine is the x value. So I'm just going to go around. I'm really going every pi over 2, or every 90 degrees, to get those values, because that's the way I have it on my table of values. So if you start here, the cosine of 0 would be 1. The cosine of pi over 2 would be 0. The cosine of pi would be -1. Cosine of 3 pi over 2 would be 0. And then all the way around, cosine would be 1. So that will kind of give you a cycle. And then if you want to go in reverse, like this, it would go cosine of -pi over 2 is 0. Cosine of -pi is -1. Cosine of -3 pi over 2 is 0. And then all the way around the circle would take you back to 1. So all I'm doing is just looking at the value of the cosine, which is the x value in a unit circle. Okay, that's it. Let me zoom on this a little bit, and let's go ahead and construct the graph. So again, always do your x-axis in radians. So that's going to be pi over 2, pi, 3 pi over 2, and 2 pi. That's as far as we're going to go out. Then do your negatives. We're going to do -pi over 2, -pi, -3 pi over 2, and -2 pi, like that. Okay, same thing we did on the last one. 1, 2, 3, 4. Kind of spread it out a little bit. So that's 1, 2, 3, 4. That's -1, like that. Okay, and then we're just going to plot points. So I'm going to kind of start here. We got 0, 1 is a point. Pi over 2, 0. Pi -1. 3 pi over 2, 0. And 2 pi, 1. Okay, connect it into a nice curve like that. Don't do it like this. It doesn't go like that. Okay, it's nice curves. And then just kind of cycle back through and plot the rest of your points. And then we'll kind of begin to see how this cosine wave goes. And what I'm graphing on this is 2 cycles right there. So a lot of what we're going to do definition-wise is repetition of what we did on the sine. It still kind of means the same thing. Okay, so that's your graph. It's a periodic function because it will continue that shape over and over again. The distance measured by x values from the beginning to the end, again, is called the period. And I want to mention on here, also with this, that you can figure out the period on this. And it doesn't really matter where you start. You could start, you can start anywhere you want to. So you would have 1, 2, 3, 4, 5 points like that. So you would kind of look at your cycles like this if you want to. So you got, that would be 1 period, and that would be 1 period like that. All right. And it doesn't really matter where you start. You just have 5 key points is kind of the key. So again, the period would be from here to there. So that would be 1 period. And notice that that's equal to 2 pi. Okay, and that's something you want to write down on there. The period of both the sine and the cosine is 2 pi. Every time 2 pi goes by, that means essentially you're making 1 lap around the unit circle. So all of the values of the cosine and sine will continue to be the same for each lap in the unit circle. That's what that means. Okay, so let's see. I just like to do this. It doesn't have, you don't have to start with like this. I usually on a cosine just kind of think of it as it starts with a max, then it goes here to an intercept, then it goes there, and it goes there, and it's back up to the max. Now you can do it this way also. You can just kind of start here, 1, 2, 3, 4, 5. It doesn't really matter. But you want to realize that you have 5 key points in every cycle. Okay, and the rest of this is identical to the sine. The domain of the cosine is all real numbers. So you can write that like that. So that's exactly the same as it was on the sine. The range is the y value. So the lowest y is -1. The highest y is 1. So you're ranging from -1 to 1. That's your range right there. So we'll just say set of y such that -1 is less than or equal to y, less than or equal to 1. Or you could say bracket -1, 1 like that. So that's the idea. Doing the basic graph is real simple. Mostly what we do in trigonometry is do transformations, kind of like you would do in college algebra. So I'm going to pause this for a minute, and I'm going to pull up an applet that I want you to look at. So I'll be right back here. Okay, presto, here I am. This is kind of what I'm wanting to show you. I don't like the way this thing works. Okay, so let's take a look at this. And just watch this. What I'm going to do is show you where that sine wave comes from in the unit circle. So remember, in a unit circle, the sine is the y value. So if you have 0 radians, the y value is 0. So you have sine of 0 is 0. Now what's going to happen is I slide through this. All I'm doing is graphing the y value on the unit circle. And when I eventually get to pi over 2, well, I'm at 1. If I'm at 90 degrees or pi over 2, we know the value of the sine's 1. Okay, then we continue. Notice the y values start going down, so the value of the sine starts going down. And then when we get to 180 degrees, or pi, then the sine on the unit circle becomes 0, and so forth. Then the y values are going to start getting into the negative numbers. So in quadrant 3, the sine is negative. So again, the y value on the unit circle is the same as the y value on the graph of the sine. When you get to 270, then you end up getting to -1. The value is -1 on the y-axis. And then finally, you begin to go towards 2 pi, and it does that. So what's kind of cool about this is the unit circle really is where the graph comes from. The sine is the y value on a unit circle. So all I'm really doing is just graphing that y value on the unit circle like that. So that's how that goes. Okay. All right. Now I'm going to show you the cosine. And we'll kind of begin to look at the cosine, if I can catch that little thing. Come on. There we go. Okay, so remember, the cosine is the x value. So if you're at 0 radians, the cosine's 1. And then what happens is that x value kind of gets smaller in quadrant 1. That x value gets smaller. We trace through there. Right now it's graphing the x value on the unit circle since it's a cosine. And then by the time you get to pi over 2, or 90 degrees, the cosine is 0. So I'm at the point pi over 2, 0. And then what happens is you start having in quadrant 2, the cosine becomes negative. So you go like this. You get to pi over 2, the cosine becomes -1. So the y value is now -1. So forth. Quadrant 3, the cosine is still negative, so we're below the x-axis. When we get to 3 pi over 2, the cosine is 0. And then we get back into the positives there. So this diagram, if you kind of look at this and study this for a while, we learned the cosine was positive in 1 and 4. So notice my graph is above the x-axis in quadrants 1 and 4, and it's below in 2 and 3. So this is a really nice diagram. You can just kind of let it run, and that's what's showing you where that comes from. So I really like that applet to demonstrate for students. Okay, so I'm going to close this off, go back to my OneNote, and then we'll go to page 3 here. So the next thing we're going to begin to talk about is what's meant by the amplitude. And the amplitude of a function is defined to be half the distance between the max and the min. And we're going to talk about how that relates to a trigonometric function here, and crunch out some things with this. Okay, so the general formula for an amplitude is you take half the distance between the max. Boy, this thing didn't come out right either. Maybe that just didn't export onto my handout okay. I hope it came out on your handout okay. That should be 1/2 the max y minus the min y. Okay, like that. So that's the formula. So if you look at this diagram right here, you kind of have a peak and a peak. So the amplitude would be half the distance from here to here. Okay, that's the distance from the max to the min, but that amplitude is always half that distance. So this is showing the amplitude from here to the x-axis. Okay, so it's always half the distance between the max y and min y. The amplitude is a distance, so a distance is always a positive number, so an amplitude is always a positive expression. Okay, so if you look at what we've learned so far, we learned the graph of the sine and cosine. So if you look at the sine, here's a graph of the sine from 0 to 2 pi like we did. Okay, well its maximum y is equal to 1. Its minimum y is equal to -1. Okay, so we have those two things, -1 to 1. If you do the amplitude formula, what it is it's 1/2 the max, 1, minus the min. You're just finding the distance between those two. So you get 1/2 of 1 plus 1. That's 1/2 of 2. Therefore, you get 1. Okay, and that absolute value is just guaranteeing that you get a positive number. Okay, so what you'd end up getting is the amplitude's 1. So in the diagram, the amplitude is from there to there. That part right there is the amplitude equaling 1. Again, it's half the distance between the minimum and maximum. Okay, the cosine isn't any different. Okay, it's got the maximum y value is 1. The minimum y value is -1. So it should turn out to be exactly the same. So your amplitude would be 1. And I think that was intended to be a cosine of x. Okay. So again, in the diagram, you can just think of half the distance from max to min is the amplitude. So that would be your amplitude equaling 1. All right. So any questions about that? Okay, you may have heard the word amplitude. It's in electronics, so like AM radio, what it stands for is amplitude modulation. You don't need to write this down, but it's worth noting that in acoustics and electromagnetism, when we're dealing with waves and stuff, well, they have a lot to do with trigonometry. Okay, so when you modify an amplitude, you're modifying the distance between the crests of the waves primarily, so you can either make them bigger or smaller. And actually, in acoustics, when the amplitude gets bigger, then the volume goes up, and if it gets smaller, as the amplitude gets smaller, the volume goes down. Okay, in electronics, that's kind of how you can think of amplitude as far as stereo systems and stuff like that. That's changing the volume. Okay, so we'll go to the next page and look at what we do when we graph something that has an amplitude change. So it turns out that when you put a number in front of sine or in front of cosine, then the amplitude changes. And the amplitude is always the absolute value of that number right there. So if you had y equals 4 sine x, then the amplitude is 4. If you had y equals -2 cosine x, then the amplitude is not -2, but it's 2. Okay, so an amplitude is always a positive number. So that will kind of tell you the distance between the crests of the waves. It's half the distance from the crest of the waves. Now what you'll learn, you actually learn this in college algebra, if a is bigger than 1, then the graph stretches vertically because the y values get bigger. Okay, and then if you have the amplitude being a fractional value between 0 and 1, then it vertically shrinks because the y values get smaller. And as we crunch out some of these, you'll begin to see what I'm talking about, I think. Okay? All right, so we're going to focus on some graphs that have amplitude changes in them. So as I move down here, the first thing we're going to do is we're just going to look at the graph. Ultimately, we're going to look at the graph of 3 sine x. Okay, and in that one, you've got an amplitude change, so I'll show you kind of what happens. First thing I'm going to do on the unit circle, since we're graphing the sine is the y value on a unit circle. So I'm just going to highlight these y values and kind of quickly fill this out. So the sine of 0 is 0. The sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi, one lap around the circle, is 0. So that's one cycle right there. If you go backwards, negative pi over 2 would be at -1. Negative pi would be at 0. Negative 3 pi over 2 would be 1. And negative 2 pi is 0. Okay? So you'll get to a point where you have the sine wave memorized. But if you don't, I mean, as long as you got the unit circle memorized, you can figure all this stuff out. So to begin with, let's go ahead and just get this broken up. Go ahead and get your x-axis labeled. It's important you always do this too. Sometimes I'll see students who don't label anything. And if you don't label anything, you're not drawing a graph. You know, if you'd be having a piece of art and it's a crappy piece of art. So, anyway, you get everything labeled, okay, before you even do anything. Get everything prepared. You have to label everything, like it or not. And always label that in radians. Okay, so we're going to do that like that. And then let's do the y-axis like this. I'm going to go ahead and make each one 1, and I'm going to go up to 3 because of that amplitude. And then let's go down to -3 like this. Okay, so you want to get everything set up. Now what you want to go ahead and do is just start plotting points, and we're only going to plot points on this first row, and I'm going to do this in red. So -2 pi 0, -3 pi over 2 1, -pi 0, -pi over 2 -1. Did I put that on there wrong? I did, didn't I? That's -1. Okay, sorry about that. So you want to get that corrected. And then 0 0 like that, and just keep going. And see, once you see the cycle, it's real easy. So it goes, starts at 0 0, hits a max, back to the x-axis, hits a min, back to the x-axis. Now go ahead and just do this in a dashed line, and then this will represent the basic sine wave, kind of like an elementary function that you would call like in a college algebra class. All right, so I'm going to label that as y equals sine x. Okay, well, it turns out what you got to understand on this, and the more you understand about the math and the arithmetic that goes on, the better you'll understand this stuff. That 3, what it does is it multiplies all of the y values on the previous graph by 3. And it makes the y values get bigger, therefore the graph vertically stretches. That's no different than in college algebra. You have a parabola, x squared, but if you multiply it by 2, it just stretches vertically. So what you want to do in your head is just do the rest of this like this. So you're doing 3 times 0 here, so that's 0. You do 3 times 1, that's 3. 3 times 0 is 0. You don't have to write that down unless you want to. 3 times negative 1 is negative 3. And then 0 times 3 times 0 is back to 0 like that. Then the rest you can just do in your head. 3 times 1 is 3. 3 times 0 is 0. 3 times negative 1 is negative 3. And 3 times 0 is 0. Okay, so that gives you your values. Now you want to go ahead and just plot this second row. So we have negative 2 pi 0. That's the same point. Then you have negative 3 pi over 2, 3. So that value stretches. Negative pi 0. Negative pi over 2 is down to negative 3. And then 0, 0. So right here, if you connect those dots, that gives you the first period or cycle of the graph that we're constructing. So it goes like that. And then you just repeat it from there. And the nice thing about graphing these trig functions, once you get the pattern, the rest of it's predictable. Now it's going to, from here, it's going to go to its max, back to the x-axis, down to the min, and back like that. So that would take us through 2 periods or 2 cycles of that sine wave like that. So what happened is, since you multiplied the y values by 3, that's what caused everything to stretch. Okay, so we call that the amplitude change on that sine wave then. A couple of observations. The period is the absolute value of that 3, so it's just 3. Okay, just think of the period always, amplitude as a positive number. So the amplitude of y equals 3 sine x is 3. I'm not sure what I was saying on this then, since the y values get multiplied by 3. I think that's what I'm talking about. Okay, all right, so that's what happens. The y values get bigger. Now we have this thing that's called a midline. And this is the first trig book I've ever taught out where they talk about this. I don't know how important it is. But the midline would just be kind of halfway between the max and min. So the midline would just be that. Okay, if you take a line that cuts it in half that way, and that would be y equals 0. So it's kind of like the halfway point between 3 and negative 3 is 0, so it's y equals 0. That's called the midline. Okay, and there's some benefit, I guess, in going over that for things we'll look at in the future. Okay, so that gives you your first example of a graph with an amplitude change. So let's move to the page 5 and work a little bit more with this. Okay, the next one we're going to do the graph of y equals 1/2 cosine x. And we're going to do, kind of start up the same way. The cosine is the x values on the unit circle. So we're going to fill out the table like this then. So let's start at 0. The cosine of 0 is 1, of course. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. Cosine of 2 pi is back to 1. So that would be a cycle through the unit circle, so that's one period of the graph. If you go backwards, you would get 0, negative 1, 0, and 1 again like that. Okay, so all that information again is coming from the unit circle. So let's go ahead and let's plot that out. And again, get everything set up. You want to take the time to get everything set up. So get your x-axis put together. And then we'll talk a little bit about how we want to do the y-axis on this problem in just a second here. Okay, there we go. Always do that. Okay, now the 1/2 is going to cause the waves to get smaller. So the biggest value on the basic cosine is 1. So what I'm going to have you do is let's go all the way up to 1 like that, and then label that as 1/2. Same thing here. Go down to, that would be -1/2, and then that would be -1. So that's the best way to set this up so your graph is pretty readable. So again, we're just going to plot these points. So you want to go ahead and plot the cosine. And here's how I know the cosine. This is what you should learn, is the cosine starts at its maximum. Then it goes to the x-axis. Then it goes to its minimum. Then back to the x-axis and back to the maximum. Okay? And then it just cycles. So this go this way. It's at x-axis, minimum, x-axis, maximum. Okay? So once you kind of get that memorized, you'll be able to do the basic graphs like in a matter of seconds, because it's not that hard. Okay, so that will be the graph of y equals cosine of x. Okay, so here's what happens. Now the next thing that happens is you basically are going to do this. You're going to multiply, when you put that 1/2 in front of a cosine, that is, you multiply all of the y values by 1/2. So really it's just going to cut all these things in half. So if you do 1 times 1/2, that's going to give 1/2. If you do 1/2 times 0, you still get 0. If you do 1/2 times -1, you get -1. 1/2 times 0, 0, and so forth. Okay, I just want you to know what I'm doing and understand the arithmetic of why that is. Okay, all that's doing is taking the value of the cosine and then chopping it in half. So then you can do it in your head. That's 1/2, that's 0, that's -1/2, 0 and 1/2 like that. Now you plot your points, and then I think you'll see what I'm talking about. So you have a point -2 pi 1/2, -3 pi over 2, 0, -pi -1/2, -pi over 2, 0, and then that. And then this right here would take you through one cycle of our graph, and then you just repeat the shape. That's the nice thing about trig graphs is once you get the pattern, then you can draw as many periods of this as you want to. So it would go like that then. Okay? All right. So just a couple of things informationally on this. The amplitude of the cosine is 1. The amplitude of y equals 1/2 cosine is 1/2, since the y values were multiplied by 1/2. Okay? And then the midline, it'd be the same as the last problem. If you look at halfway between the max and the min, which is here, would just be the x-axis. So the name of that, the equation of the x-axis is y equals 0. So that's the idea. Okay, back on the previous page here real quick, when I was filling out these problems, I may have been a little bit confused there. And yeah, I just got to change this. It's not a big deal, but the the amplitude of sine x is 1. Okay, the amplitude of 3 sine x is 3, because the y values get multiplied by 3. I just realized that I didn't do that correctly. Okay, so I'll kind of pause here for a minute and let you kind of see if you've got any questions about that. Mostly, it's just doing arithmetic and plotting points. That's what graphing really boils down to. Okay, so a couple other things I want to do at the bottom of the page, and then I'll let you probably work on a couple of problems to finish this first part of this lecture up. So, given this particular thing, y equals 10x. The amplitude is the absolute value of that number, so that's 10. That's going to tell you the maximum is 10 and the minimum is -10. So if you did a graph of 10 sine x, the highest point would be at y equals 10, the lowest would be -10. And since it's symmetrical, that midline would be y equals 0. And that is just halfway in the middle of 10 and -10. Part B, the amplitude is the absolute value of -5, so it's 5. Just always remember that an amplitude is a distance Therefore, it's always a positive number. The max would be 5, the min would be -5, and the midline would be 0. Okay, so still the same idea. If the amplitude's 5 on this problem, then you would have 5 and -5 as the max and min. That'll change as we start doing more transformations. Okay, so what I'm going to have you do next is I'm going to have you fill out the problem 1 and 2 at the bottom of the page, and then I'm going to have you do 2 graphs, and then that will end up this part of the lesson. So I'm going to go ahead and pause this. I think I've got a unit circle on the next page to help you. So go ahead and do that, and then come back and check and see if you did these right. Okay, so I've worked them all out. Let's just kind of go through and check your work. If everything's good, then you're good to go with the beginning of graphing a sine and a cosine. Okay, and then in the next parts of the video, we'll look at other types of things. So that you should have got amplitude of a third, max a third, min a -third, y equals 0. The midline's y equals 0 always for now. That'll change once we start moving our graphs up and down. Second one, amplitude, of course, is 8.5. Max is 8.5. Minimum's -8.5. Midline's y equals 0. So you don't need to graph those. You need to just know from those graphs that we have that. And don't forget on the amplitude, you're doing the absolute value of that number because amplitude is a positive number. That's very important. Okay, let's check your graphs. I'll go ahead and move down to this one, let you check this and see if you did this right. So all this came from the unit circle, so you want to make sure that you have all your values on the sine accurate. And then what I did, again, is I just multiply all of the y values by 2.5. So your graph should have got stretched vertically. The maximums go up to 2.5, the minimums go down to -2.5. So again, I just multiply all the y values by 2.5. You want to make sure you have that. And then graphically, make sure you label your x-axis like that. You may have done your y a little different than I did. I went ahead and did 1, 2, and then 2.5. You know, I like to kind of, spread things out as much as I can so they're a little bit more readable. So that's what your graph should look like. You can see that the maximum stretched to 2.5, the minimum stretched down to -2.5. And then you would fill out the amplitude of a sine. A basic sine has an amplitude of 1. 2.5 sine has an amplitude of 2.5, max and min, and then the midline. Okay, midline is y equals 0 unless you have what's called a vertical translation, which we'll look at later. Okay, pause if you need to correct anything. Otherwise, I'm going to move on to the second one and let you check over how you did on this one then. Okay, so on the second one, what you have on this is make sure that your row for the cosine is accurate. And then what we're doing is, because of that -3, we're multiplying y values by 1/3, or by -1/3. Now that's going to cause this graph to reflect. I didn't do one like this, but I wanted you to do one like this yourself so you can see why that is. So what happens is when I multiply, +1 by -1/3, I get -1/3. And -1 times -1/3 becomes +1/3. So those y values reflect over the x-axis as a result. So you want to make sure you did all your arithmetic correct and got that accurate. Then your graph goes like this. The red one is the cosine. That's the basic cosine. And then the other one is going to be the final product. So that would be y equals -1/3 cosine x. Okay, like that. Okay, so just make sure that your points are plotted. A logical way to do this to me was to make 3 notches 1 and then divide it up into thirds. Okay, do it that way. See, if you made this 1, your graph would be like so tiny I could hardly see it. So, it's worth fixing that if you didn't do it that way. And then make sure that you had amplitude of cosines 1, 1/3's the amplitude of the graph -1/3 cosine x, max 1/3, min -1/3, and midline y equals 0. So from experience, usually students don't seem like they have much trouble doing these graphs. They get a little bit harder as we begin to put more and more stuff together. So that will end this part of the lesson, and hopefully that'll go good for you. Then I'll be recording a couple other parts on this. So good luck.